Welcome to the last topic in our chemistry series, organic chemistry. So we're going to start with the introduction, then we'll move to a group of compounds called alkanes. Then we'll move to a group of compounds called alkenes, then alcohols, then carboxylic acids and esters, and we'll end up with a special group of compounds called polymers. Let's get started. So organic chemistry is simply the study of carbon compounds except carbonates, carbon monoxide, carbon dioxide, carbon disulfide, etc. So all carbon compounds other than these ones such as carbonates, carbon monoxide, carbon dioxide, carbon disulfide makes up what is called organic chemistry. So we're going to start with some of the common terms that are used, and we're going to go deep into some terms so that we understand them fully as we venture on this topic. So the first is organic compounds. Okay, so what are organic compounds? So organic compounds are compounds which contain carbon except carbonates, carbon monoxide, carbon dioxide, carbon disulfide. In short, organic chemistry is the study of organic compounds. Next, hydrocarbons. What are hydrocarbons? A hydrocarbon is a compound which consists of the elements carbon and hydrogen only. So any compound which has carbon and hydrogen only is called a hydrocarbon. So organic compounds is made of hydrocarbons and other compounds which are not hydrocarbons. So an example of a hydrocarbon is this compound called methane, whose chemical formula is CH4, made of 1 carbon atom and 4 hydrogen atoms. Then we also have ethene, which is made of 2 carbon atoms and 4 hydrogen atoms. As you can see, there's only carbon and hydrogen here, making these to be hydrocarbons. Then we also have ethane, which is made of 2 carbon atoms and 2 hydrogen atoms. Next, the next term is homologous series. What does it mean? A homologous series is a family of similar organic compounds. So organic compounds have been grouped depending on their characteristics or the way they are prepared. So they have been grouped into families. The families are called homologous series. So each member in a family is called a homology. So just going deep into what makes such families, here are some characteristics of the homologous series. In short, the characteristics of the families. First, the members in the family show a gradual change in physical properties. Members in the family have similar methods of preparation. Members in the family have similar chemical properties because they have the same functional group. Okay, so we've talked about having a gradual change in physical properties. What this means is we can have maybe some members being solids, then others are going to be liquids, others are going to be gases. So that's what it means by a gradual change in physical properties. So it depends on the family, and of course the physical property there is somehow tied to that family. It can be temperature, it can be density, but there will be gradual change. Also, because of different because of being in the same family, members also can be prepared using similar methods. And the last point talks about a functional group. So this point emphasizes on the fact that the chemical properties are determined by something called a functional group. So this functional group gives a given family its chemical property. The very reason why there are different families, meaning that there are different chemical properties determined by the functional group of that family. What is this functional group? So before we can address what a functional group is, another thing about homologous series is each member in the family differs to the next by CH2. So the members in homologous series are arranged in a specific sequence. Like there's this member, then after this there's this. They're like children of a family. There's a firstborn, secondborn, thirdborn, just like that. So even these members of the homologous series are arranged in a certain way, and the consecutive members differ by CH2. What it means is they differ by 1 carbon and 2 hydrogen atoms. Okay, so each family differ, the members of each family differ by CH2 if they are following each other. Okay, so if there is this member and then there's another member, if the way they are arranged they are following each other, then they are going to be different by 1 carbon atom and 2 hydrogen atoms. It will become more clear as we visit the families. So another thing is members in a family can be represented by the general molecular formula. So members in a family have what is called a general molecular formula. Each family has its own general molecular formula. Examples: there is a family called alkanes. The general molecular formula for alkanes is CnH2n plus 2. What it means is the number of carbon atoms is somehow connected to the number of hydrogen atoms. If there is 1 carbon atom here, mean that our N is 1, then you can put N here, and if you solve, try to find out the number of hydrogen atoms, it's going to be 2 times N plus 2. Since N is 1, so it's going to be 2 times 1 plus 2. 2 times 1 is 2 plus 2, 4. Mean that if there's 1 carbon atom, there's going to be 4 hydrogen atoms. Another example is, let's say we have 10 hydrogen atoms here. So we're going to put 10 here where N is. So it will be 2N plus 2. So it will be 2 times 10 plus 2. 2 times 10 is going to be 20 plus 2 is going to be 22. So if there are 10 hydrogen atoms, they are going to be 22. If there are 10 carbon atoms, they are going to be 22 hydrogen atoms. Another family is called alkenes. So for the alkenes, again, this is their formula. It's different from this family. So this is their general molecular formula, CnH2n. So the thinking is the same. If you have 5 carbon atoms here, then it means here you're going to have 2 times n, where n is 5 since we have 5 here. So it's going to be 2 times 5 and to give us 10 hydrogen atoms. The next are alkynes. So the general formula for these alkynes is CnH2n minus 2. Meaning that if we have 6 here, for example, here we're going to have 6, so 2n minus 2. So 2 times 6 minus 2. 2 times 6 is going to be 12 minus 2 is going to be 10. So if we have 6 carbon atoms here, we're going to have 10 hydrogen atoms. The next are called alkanos or alcohols. Their formula is CnH2n plus 1 OH. So this OH is always there, but here it's CnH2n plus 1. The number of carbon atoms is connected to the number of hydrogen atoms, but there will be 1 hydrogen atom that will forever be connected to oxygen, and it is not changed by the number of carbon atoms. So if we have 2 carbon atoms here, then the number of hydrogen atoms, these ones, is going to be 2 times n plus 1 or 2 times 2 plus 1, which is going to be 5. So we're going to have 2 carbon atoms, 5 hydrogen atoms, but the OH will still be here. This OH is a functional group, as we are going to see later. Then we also have alkanoics. So alkanoics are also called carboxylic acids. Their formula is CnH2n plus 1 COH. So again, I won't give an example. I'm sure you understand. So this COH is not influenced by the number of carbon atoms at first and the number of hydrogen atoms. In short, there will always be a COH that is not changed by the number of carbon atoms. So there will be one carbon atom which is connected to one oxygen atom which is connected to one hydrogen atom, but the remainder of the carbon atoms and the hydrogen atom are going to vary depending on what is available. Now go to functional group. We said that a functional group is what gives a family its chemical characteristics. A functional group is just a group of atoms which determines the chemical properties of a given family of organic compounds, and that's the definition of the functional group. So let's take a look at some of the families and their functional groups, and of course the names of these functional groups. So here we have the families, here of the functional groups, here of the names of the functional groups. So alkanes, the functional group is just a carbon connected to another carbon by this one line. This one line means a single bond. A single bond means there are two electrons here. It means carbon has contributed an electron and another carbon has contributed an electron. So there's just a pair of electrons here that makes this bond. So the name of this functional group is single carbon to carbon covalent bond. The next are alkenes. So alkenes, instead of having a single bond, they have a double bond. So this double bond is the functional group. One carbon and another carbon, then having a double bond is what makes alkenes alkenes. And the name, of course, is double carbon to carbon covalent bond. Then after alkenes, we have alkynes. So alkynes, instead of having a single or a double bond, they have three bonds here, a triple bond. Okay, so this triple bond between two carbon atoms is what makes alkynes alkynes. And the name, of course, is triple carbon to carbon covalent bond. Then we go to alkanos or alcohols. So for alcohols, we have OH. This is the functional group. Any alcohol should have this. This is what makes alcohol alcohol. So this is called a hydroxyl group. A hydroxyl group. Then after this, we have alkanoics or carboxylic acids. So what makes carboxylic acids? Carboxylic acids is this group of atoms, one carbon, two oxygen, one hydrogen. I think in the previous example, we had one oxygen here. I'm sure it was a mistake. It's supposed to be two oxygens here. So it's one carbon, two oxygens, and one hydrogen atom. Then sometimes they don't just like to write them like this. They write them with their structural formula. Structural formula is how the different atoms are connected to each other. So this, when written in form of the structural formula, is oxygen double bonded to carbon, single bonded to another oxygen, which is single bonded to hydrogen. So this is called a carboxyl group, and is what makes carboxylic acids carboxylic acids. There is also another family called esters, which we're going to start later, and I'll give the functional group and everything. This was just an overview of the different families we're going to study as we venture on this. Of course, maybe one won't be studied, but this is just the overview. Next, we go to nomenclature of organic compounds. Nomenclature is about standardized ways of naming organic compounds. So, any name of an organic compound is made of two things. One, the prefix. Two, the suffix. For those who remember physics, there was a topic called prefix. prefix simply is a word at the beginning of another word. Like we have this word, so it has two parts. At the beginning, the word that is at the beginning is called a prefix. Then a suffix is the word at the end. Let me say that maybe you are confused. So a prefix are letters that are at the beginning of a word that gives meaning to the whole word. Because of their presence, they give a certain meaning to the whole word. Well, a suffix are letters at the end of a word that, because of their presence, gives a certain meaning to that word. So as we are going to look at examples of prefixes and suffixes, we're going to see that it is as simple than the way you might try to imagine it right now. So in organic chemistry now, the prefix shows the number of carbon atoms in an organic compound. So the group of letters at the beginning of a name of an organic compound gives you the number of carbon atoms in an organic compound. Well, the suffix shows the organic family of the organic compound. The suffix shows you the family it belongs. The prefix shows you the number of carbon atoms. It's like the suffix is more like the surname, which shows the family. Well, the prefix is like the first name, though it doesn't show the number of carbon atoms, but the prefix shows the number of carbon atoms, unlike the first name of people, which doesn't show the number of carbon atoms. Okay, forget that comparison. Yeah, let's take a look at some examples of prefixes. So these prefixes are derived from some Greek language and the likes, so you need to know them. So the word meth means one carbon atom. The word earth means two carbon atoms. The word prop means three carbon atoms. The word boot means four carbon atoms. Pent is five carbon atoms. Hex is six. Hept is seven. Oct is eight. Non is nine. And dec is 10. So these ones, if you see, this is October, November, December. But don't confuse yourself. I'm just trying to show you that even the months, that's where they are taken from the same language as these prefixes. Okay, so you have to master what dec means, non means, oct means, and the likes, all of them, at least up to dec. Then the suffixes, we're going to have these families and the suffix we use to show the family. So if an organic compound belongs to alkanes, then the suffix is ane, meaning that that organic compound at the end of the name should have ane. If the family is alkenes, then it should have ene. If the family is alkynes, it should have yne. If the family is alcohols, it should have anol. Carboxylic acid should have anoic, and esters should have anoate. So these are the suffixes. So let's take a look at an example. So name the following organic compounds. So the description of this organic compound is it has 5 carbon atoms and is an alkane. So the fact that it has 5 carbon atoms, the prefix for 5 is pent. Then the fact that it belongs to the alkane family, the suffix for alkanes is ane. So if you combine these two, they become pentane. The second is 7 carbon atoms and is an alcohol. So 7, the prefix is hept, and the fact that it is an alcohol, it means the suffix is anol, making this heptanol. Then another one is 1 carbon atom and is an ester. So 1 carbon atom, the prefix is meth, and the ester family the suffix is unweight, so this becomes methanweight. So this is how to name organic compounds. This marks the end of this introductory part of organic chemistry. Happy solving!